Causal inference is the process of determining the effect of a treatment. The causal impact can be evaluated by randomized experiments or observational studies. A randomized experiment randomly separates the samples into the treatment group and the control group. The causal impact can be calculated by getting the difference between the treatment group and the control group. When only the observational data is available, we can use causal inference algorithms to calculate the causal impact. Such algorithms include but are not limited to difference in difference, matching, inverse probability treatment weighting, and counterfactual modeling. This is Amy from Grab and Go Info. In this tutorial, we will talk about how to use Mahalanobis Distance Matching for causal inference using the R package matching. You will learn how do the matching algorithms work, how to do Mahalanobis Distance Matching using R, how to do causal inference using matched data, how much improvement in accuracy is made by causal inference. Let's get started. Matching takes a sample in the treatment group and finds a similar sample in the non-treatment group. The goal of matching is to create the treatment group and the control group that are comparable. The matching process involves the following steps. 1. Compute a distance between the subject in the treatment group and the samples in the control group. The distance can be calculated using the confounders or using the propensity scores. In this tutorial, we will do the matching on confounders. 2. Match subjects in the treatment and control group using the shortest distance. There are different ways of calculating distances. We will use the Mahalanobis distance matching in this tutorial. It is similar to the Euclidean distance. The difference is that Mahalanobis distance matching uses the standardized data while Euclidean distance uses the original data. 3. Define a caliper as the maximum distance threshold we are willing to accept. A small caliper means a small distance threshold, a better balance between treatment and control group, a smaller number of matched pairs, and we get results with less bias and more variance. A large caliper means a large distance threshold, a worse balance between treatment and control group, a larger number of matched pairs, and we get results with more bias and less variance. In step 1, we will install and import libraries. Firstly, let's install DAWI for dataset creation. Then, we activate the R magic command in the Google Colab notebook using RPY2 and install the R packages table 1 and matching. This tutorial uses both Python and R in the same Colab notebook. To get details on using R with Colab, please check out my tutorial how to use R with Google Colab Notebook. After the installation is completed, we can import the libraries. The datasets is imported from DAWI for dataset creation. Pandas and NumPy are imported for data processing. Packages from RPY2 are imported for Python to R conversion. Then we imported the two R libraries, Table 1 and Matching. To get the code for this tutorial, please check out my blog post on medium.com. I will put the link in the video description. Medium.com is my most referenced website for data science and machine learning. It charges $5 per month for full access. I have been a Medium.com member for many years, and that's the best $5 I spent every month. If you would like to support me as a content creator and buy me a cup of coffee, please use the link in the video description to join the Medium membership at no additional cost. If you prefer not to join, you can still read the post because there are a couple of free posts each month for everyone to read. Okay, let's continue. In step 2, we will create a synthetic dataset for the causal inference. Firstly, we set a random seed using np.random.seed to make the dataset reproducible. Then a dataset with the true causal impact of 10, 4 confounders, 10,000 samples, a binary treatment variable, and a continuous outcome variable is created. After that, we created a data frame for the data. In the data frame, the columns W0, W1, W2, and W3 are the 4 confounders. V0 is the treatment indicator, and Y is the outcome. Next, let's rename V0 to treatment, rename Y to outcome, and convert the Boolean values to 0 and 1. Finally, the Python data frame is converted to R data frame in order to use R packages on the dataset. In step 3, we will get the direct difference between the treatment group and the non-treatment group. We can see that for the group that received the treatment, the average outcome is about 14, while for the group that did not receive the treatment, the average outcome is about -2. If we do not use causal inference and take the direct difference between the two groups, we will draw the conclusion that the treatment increased the outcome by 16, which is much higher than the true causal impact of 10. In step 4, we will check the standardized mean difference between the treatment group and the non-treatment group. var equals confounders means that we will summarize the data for the 4 confounders. Strata equals treatment means that the variables will be grouped by the treatment type. Test equals true means the p-value for the significance testing will be reported. SMD equals true means that the standardized mean difference will be reported. Standardized mean differences greater than 0.1 means that the data is imbalanced between the treatment and the control group. We can see that most of the confounders have SMD greater than 0.1 and a significant p-value, meaning that the confounders that different between the treatment group and the non-treatment group. In step 5, we will perform Mahalanobis distance matching on the dataset using match in the R matching package. TR takes in the treatment indicator column. M=1 means one record in the treatment group is matched with one record in the control group. X takes the list of confounders to match on. Match returns objects index, treated and index, control to reconstruct the matched dataset. Table 1 results show that after matching, the test and control are still significantly different for some confounders. So we need to add a caliper. A caliper is the distance threshold for any match. The matched pairs with a distance greater than the caliper distance will be dropped. Caliper equals 0.2 means that matches greater than 20% of the standard deviations of each confounder will be dropped. We can see that after adding the caliper, the standardized mean distance decreased and the p-values are not significant, meaning that the match treatment and control group are not significantly different from each other for all the confounders. In step 6, we will calculate the causal impact on the matched dataset. Firstly, we get the outcomes for the matched treatment samples and the matched control samples. Then a paired t-test is performed to check if the mean difference is equal to 0. From the output of the paired t-test, we can see that the p-value is close to 0, meaning that the outcome mean of the treatment group is different from the outcome mean of the control group. The 95% confidence interval is between 10.12 and 10.21. The outcome mean difference is 10.1649. Which is very close to the true causal impact of 10. Compared with the direct difference without matching of 16.13, the Mahalanobis distance matching increased the accuracy by about 60%. If you have made it this far, you probably find the information in this tutorial helpful. Please click the like button and subscribe to the channel to get notified when I publish new videos like this. To learn more about causal inference, please click the YouTube playlist on the screen now. Thank you for watching and see you in the next video.